Good morning, students. How are you all? Hope all are fine and safe at home. So, students, today we will continue chapter 2, page number 19. So, the topic is how to separate the various components of a mixture. In this chapter, we will be doing 7 to 8 methods of separation. And in all the methods, students, please note it down. In all the methods of separation, you will be doing principle. Principle means on the basis of what that method is applicable, basis, theme. Then application, that is uses, few important examples, and activity, that is procedure. This activity procedure to be done only in few methods, but in all methods you have to do principle, application, and examples. Which procedure you have to do in detail, that I will tell you at the last of the chapter. Right? So first we will start with the method left side. First is how to separate the colored components from blue black ink. So first of all, write the method name evaporation. Written? So what is the principle for evaporation method? The principle is to separate volatile solvent from its non-volatile solute. What are volatile? Volatile means which easily gets vaporized, right? Non-volatile which doesn't, right? So it is used in that mixture in which one of the component is volatile and one of the component is non-volatile. So when we heat them, the volatile solvent, it will easily get vaporized, leaving behind the useful component, that is non-volatile solute, right? This is principle. So how we will do this method? The procedure apparatus setup. First of all, we'll take a tripod stand. It is known as tripod because it has 3 stands, right? Over it, we will put a wire gauge. You can see wire gauge so that uniformly heat is distributed. Now, whichever chemical dye you have to separate, you will not keep it directly over it. No. What you will do? First, we will put a beaker. First, we'll put a beaker full of water. So first we'll take a beaker and we will add water in the beaker, right? Then when the water gets heated up, then we will put watch glass. Students, everyone see here, this is watch glass. We'll put over the beaker. Then we will take china dish. I hope you all have seen, We'll put china dish over it. And in this china dish, we will put the mixture, whichever you have to separate. You will not put directly the mixture here, otherwise it will burn, right? So what we'll do, first we will burn the burner, light the burner, then we will put wire gauge, then we'll put beaker, then watch glass, and then china dish. The heat will, first of all, heat up the water. After water gets boiled up, it will pass on the temperature, the heat to the china dish, and slowly the volatile components will be separated from the mixture, leaving behind non-volatile which we require. So you can do any 2 types of burner, either the burner connected to the cylinder or a spirit lamp, right? So this is the apparatus setup for evaporation method. I hope you have understood this. Now the second principle you can mark, right side, second line, write the heading principle. And repeatedly I am saying you have to learn principle and application of all the methods. Principle, we can separate the volatile solvent from its non-volatile solute by this method. Now second method is how can we separate cream from milk? I have told you in my previous lecture also, in the colloidal mixture, filtration method is not applicable. A unique method is there, that is centrifugation, a very special method, and you all have seen at home also. So first of all, you write the method name centrifugation, centrifugation. You all have seen this method at home also. Your mother might be separating butter or cream from milk in mixer grinder, that is method of centrifugation. So what is the principle for centrifugation? The principle is the denser particle, denser means heavy particles, they are forced to settle down at the bottom and the lighter particles float, that is they stay at the top when rotated or spun rapidly. I have marked, underlined the important words. Heavy particles, they are settled down. Lighter particles, they stay at the top when spun, rotated rapidly. Right? Like you all have seen at home also. And today I have prepared a starch solution. You all can see starch is an example of colloidal solution. Right? So this starch solution we will put in a centrifugal machine. So that is centrifugal machine. This is centrifugal machine in a school lab. Same centrifugal machine is used in diagnostic lab when you go for blood test or urine test. Right? So these are test tube stands. We put test tube here and then we will close it. We will switch on it and it will spun rapidly for few minutes. Right? So I have switched on. You can hear the sound also. The test tubes are rotating rapidly inside. We have to wait for few minutes. And after few minutes you will see that heavy particles settle down and lighter particles, they are at the top. So let us see. See, I have rotated it for few minutes and now you can see that the heavy particles have been settled down and the lighter particles, they are at the top. Heavy particle you can see at the bottom. This is starch solution. Same thing your mother do at home, right? So this was about centrifugation method. So you mark the principle. It is given on page number 20, left side top. The principle is denser particles are forced to the bottom and lighter particles stay at the top when spun rapidly. This is the most important point, spun rapidly. And this is example, mainly this method is mainly applicable for colloidal solutions. Starch is colloidal, milk is colloidal, soap solution is colloidal, blood is colloidal. So these are application for blood testing and urine testing in dairy farms, at home, and also to squeeze out water from wet clothes. So that was centrifugation. And the next is how can we separate mixture of two immiscible liquids. What are immiscible? Immiscible means which are insoluble, which don't dissolve with each other. That is miscible liquid. Like if you take water and milk, easily soluble, water and ink, easily soluble. So they are miscible liquid. But these are immiscible, which are not soluble with each other. The best example, and you all have seen, is oil and water. Right? So first write down the method name here. The method name. It is not a method, basically it is an apparatus which is used, that is separating funnel. Separating funnel. So what is the principle for separating funnel? It is used in those mixtures which are immiscible, which doesn't dissolve with each other. So what is the principle? To separate two immiscible liquids where they form different layers depending on the density. Depending upon the density, like you can see, this is a separating funnel. We have taken oil and water. We all know oil is lighter and water is heavier. So when we put the mixture in a transparent separating funnel, oil will form a top layer. This is a stopcock. We will lose it. So drop by drop water will move down. When little bit water is left, we will tighten the stopcock little bit, and when last drop reaches to this point, immediately we will tighten the cork and kerosene or the oil is separated from the water. So this is diagram of separating funnel. Students, you have to prepare this diagram for your exam. You have to prepare this diagram for your exam, separating funnel, right? And principle is given. The principle is that immiscible liquids separate out in layers because they have different densities. Densities means some are lighter and some are heavy, right? So applications, these two applications are written, right? To separate mixture of oil and water. And second is when we do obtain iron from its ore, this method is applicable. The molten iron we separate by this